Today question is 2425 bitwise XOR of all pairing. Before going inside the question, let's move on to XOR first and then we will come back to the question. XOR, also known as exclusive OR, is a logical operator that compares two values and it returns true when the values are different and false when they are same. So let us look into this. What will be the value here? Since both are same, we will be getting 0. Since both are different, we will be getting true, that will be 1. Both are different, again we will get 1. Both are same, we will get 0. So here we have 5, 2 and 7 and we have their binary representation. So if we do 5 XOR 2, so it will be like 101 XOR 010. That will be these both are different, then 1 different 1 different 1, and if we look it will be 7. And if we do 5 XOR 7, it will be 101 and the 7 will be 111. And if we do these two are same, then we will get 0. These two are different, we will get 1. These two are 0, like same, that's why we will get 0. And another property, that if we do 5 XOR 5, then both will be same, so we will be getting 0. Let's look at this. 101 101, both are same, 0 same, 0 same, 0, and this will be equivalent to 0 in hexadecimal. Now another property of XOR is it is associative. That means if we do A XOR B and then XOR C, or if we do B XOR C and then XOR A, the answer will be same. That means order does not matter. So now let's look it with an example. Here A we have taken 2 and B as 5 and C as 7. So here 2 XOR 5 and here XOR 7. I am first solving the left hand side. So it will be, as we have seen, 2 XOR 5 or 5 XOR 2, it will be 7, and 7 XOR 7, something XOR with itself is 0. Now let's look at the right hand side. 2 XOR 5 XOR 7. If we look here, 5 XOR 7, it corresponds to 2. So again it will become 2 XOR 2 and again it will be 0. So here we have proved that XOR is associative and order does not matter. Now let us have a look at our question. We have two arrays nums1 and nums2 that have non-negative integers. Here you can see. And we have another array nums3. How it is getting created? When we are doing XOR of all pairing of integer between nums1 and nums2. That means that if you see, the XOR of 2 and 10 is 8, and then XOR of 2 and 2 is 0, as we have seen with the property. Then XOR of 2 and 5 as 7, we have seen already. XOR of 2 and 0 is 2, we have seen. Similarly XOR of 1 and 10 11, we have seen. So like this we have this array nums3, and what we are doing in the end, we are doing the XOR of all the elements that will equivalent to 13. That is written here. Return the bitwise XOR of all integers in nums3, 13. So what will be the intuition for this question? In coming to intuition, we have learned 2 points. First point is the order does not matter. And second point, if we do XOR of same element, we will get 0. Or we can say if we do XOR in even number of elements, like here it is 2, 3, 4. So XOR of these two is 0, XOR of these two is 0, and XOR of 0, 0 will be 0. So even when the elements are in even number, their XOR will be 0. So I thought let's see how we can solve this problem. I feel like something of this property we will be using it. So nums1 length I can take as 2 and nums2 length I can take as 4 for this example. Like I thought of okay, let's take it A and B, and here I'm taking nums1 as A and B and nums2 as C, D, E and F. So let's see, if we do pairing of A and C, it will be A XOR C, then A XOR D, A XOR E, A XOR F. Similarly, B XOR C, B XOR D, B XOR E and B XOR F. Now in the end what we have to do, we have to do XOR of each of these. So that will be A XOR C, XOR A XOR D, XOR A XOR E, XOR A XOR F, XOR B XOR C, XOR B XOR D, XOR B XOR E, XOR B XOR F. Do you notice something? See, since this nums2 the length is 4, that means that this A will come 4 times. If you see 1 2 3 4, and similarly B will also come 4 times, 1 2 3 4. So what we see, if we write it together, A and similarly B, since order does not matter, we can directly see our answer here is 0 XOR 0. And similarly for the same case, if we look at C and we see the size of this nums is E1, that means that C will come 2 times. One is here, another one it is here. So it will be C XOR C, and again it is an even number, it will come as 0. So we can say that if it is E1, N1, length of array 1 is E1 and length of array 2 is also E1, then our XOR of total array nums3 will equal to 0, as I have shown here. Okay, now we have seen one case, first case where N1 is E1 and N2 is also E1, then our answer is 0. Second case, when N1 can be odd and N2 can be even, or different of this, like N1 can be even and length of N2 can be odd. What happens in this case? Let's see. Again, nums1 I am taking as A and B, and nums2 I am taking as C. So here the length is what? Even 2, and the length is 1, that is odd. So what is happening here? Again, if I do XOR of this, then it will be A XOR C and again B XOR C. And if we try to do XOR of these two, it will be A XOR B XOR C XOR C, and again this will become to 0. And what is this A XOR B? It is the XOR of this array. Understood? So what is happening, that if the length of the array which is even and the length of the another array is odd, then since the odd array will be like present in even number of times because of this length, so it will be cancelled out. Let us take another example. In this case, nums1 I am making as odd and nums2 as E1. So what will happen again? Like A, D, A, E, B, D, B, E, C, D, C, E. And if we do XOR of all these, so A is coming how many times? 2 times. So it will be 0. B is coming how many times? 2 times. It will be 0. C is coming how many times? 2 times. It will be 0. Then what we are left with? Oh, sorry. D is coming how many times? 3 times. So if you see these 3 times D is coming. So out of 3, 2 will be cancelled and it will be 0. Similarly for E is coming 3 times. See. So how many times it will be there? And it will become 0. So in the end, what we are left with? This. What is this? XOR of this element. So what we can say, if either one of them is odd and another one is even, then the answer will be XOR. Second case, odd and even present, then our answer will be XOR of elements of even array. Now coming to the last case, third case, where both n1 is odd and n2 is odd, then what happens? It will be similar to this case only, as in the end we are left with only one of the elements. So if we think, right, A, B and C, and nums 2 can we do E, D, then A XOR D, B XOR D and C XOR D. And if we make it like this, A XOR B XOR C XOR D XOR D XOR D, it will cancel out. So what is this point? It is the XOR of this array. What is this? XOR of this array. Or we can take a bigger example. Here A, B, C, and this is nums 1 and nums 2 will be D, E, F. Then again AD, AE, AF, BD, BE, BF, CD, CE, CF. What will happen? Even number of times cancel out, only one will be remaining, that will be odd. So let me prove it. The one that cancels out, I will say this A cancels this A, then this B cancels this B, then this C cancels this C. Similarly for D, this D cancels this D, and this E cancels this E. Now coming to F, this F cancels this F. What we are left with? 1A XOR, then we are searching a B XOR, then we are searching a D XOR, E XOR, C XOR F, and if we rearrange it, A XOR B XOR C, A B C XOR D XOR E XOR F, D E F. What is this portion? XOR of this element. What is this portion? XOR of this array. So if both are odd, then what will be the answer? XOR of all the elements of n1, nums1, and XOR of all the elements of nums2. That will be our final answer. Now let's code it and complete this. Okay, so first of all we take the length, that will be nums1 and nums2. Then let me create a helper function that will give me the XOR of the past array. Here we are getting the XOR of all the elements in the array. We have to return it. Okay. Now according to all our cases, the first case, if n1 is also even and n2 is also even, then what we will do? We will return 0. Else the second case will come if n1 can be odd and n2 will be even. Then what we have to do? We have to return the XOR of which the one that is even, that will be nums2. Again in the second case only, this times n1 is equal to even and n2 is equal to odd. And what we'll do? XOR of nums1. The last case, when both are having even, then what we will do? I'll try to run it. Yeah, let's try to submit it.